고마워. 어느 부분이 어려웠어? 다 어려워.
remainder 남기는 게 잘 아직 이해가 안 가서.
오케이. 해보자. 오케이. 그럼 dividing polynomial 그 remainder 없는 것부터 시작하자. 1번부터. 예, 우리 문제가 2x to the 5th plus 5x cubed over x. 이건 쉬웠지? 이건 유겸이가 해볼래?
답은 2x to the power 4 plus 5x squared.
2x to the power 4 plus 5x squared. That should be right. 다 이거 나왔지? 이건 쉬웠지 엄청?
네.
이 부분 그냥 건너뛰자. 다음 부분 어려웠던 부분. 그럼 바로 내려가면 3x squared minus 5x plus 2 over x. 아이고, over x. 이거 풀 수 있었던 사람 있어?
저요?
예지가 풀었어?
네.
얘 답 뭐 나왔어?
저 3x minus 5 plus 2 over x.
Plus 2 over x. Okay. Does anybody need explaining on how to do this? Since you guys said remainders were hard, I'll go over it one time. Go over this example one time. So we're dividing by x. So we change it so we can divide it in this form. And we see how many times does x go into 3x squared, right? That's 3x times, since 3x times x is 3x squared. And we put it in this column, since this is x, right? We want it to be in the same terms, and we multiply 3x times x is 3x squared. We subtract, leaving 0, and we bring down negative 5x. How many times does this go into negative 5x? Well, negative 5 times. We multiply again, and we subtract, leaving 0. Take down 2. How many times does 2 go into x? Well, that's impossible, so 2 is our remainder. That's our answer, and this is our remainder. So how do we write this, right? How do we write our answer? Well, we write our answer first, and our end portion is gonna be the remainder over the divisor, remember? And our divisor is what we divide by, which is x in this case. What's our remainder? Well, we got 2 here. So 2 over the divisor, which is x, over x. So we get this answer. Does that make sense to everyone?
Yes.
Okay, nice. Let's move on to the next question. The next question was x to the 4th plus 2x squared minus 5 over x. 이건 지원아 이거 풀었어?
방금 풀었어요.
방금 풀었어?
네.
오케이. 답은 뭐 나왔어?
I got x to the 3rd power plus
Uh-huh.
2x
plus
minus
2x
minus 5 over x.
minus 5 over x. That should be correct. Did everybody else get this?
Yeah.
Okay, let's move on. And our next question, our final question for this section is 5x squared plus x plus 6 over x. 이건 시우가 풀어보자.
5x
Mhm.
plus 1 plus 6 over x.
Plus 6 over x. That's right. Okay. Moving on. Linear factors. These are a bit harder. Let's try one question with no remainder. X squared plus 6x plus 9 over x plus 3. 이건 민혁이가 해줄 수 있어?
이거 x plus 3.
X plus 3. That's correct. Let's move on from this section and do the ones with remainders again. Our question is x squared minus 5 over x minus 2. 이건 예지가 해보자.
저 사실 이거 어떻게 푸는지 몰라서 별표 했는데.
형,
안녕?
저 지금 예승이랑 같이 있어서.
오케이. 같이
네.
수업 들어?
네네. 예승이 집에 있어가지고.
오케이.
네.
이건 조금 어려웠을 거야. 왜냐면 중간 term이 없잖아. 그래서 나눌 때 좀 어려웠을 거야. 일단 적어보자. x minus 2 over x squared minus 5. I'm gonna leave a space here. I'll explain it later why I'm doing it. It's because, actually I'll explain it now. It's because we don't have a middle term, but we still might have to write something here. So we ask ourselves, how many times does x go into x squared? Well, x times, right? We don't write in this column or this column, we have to write it in this column. So x times, we multiply now, x times x minus 2 is gonna be x squared minus 2x. This is basically a 0. 0 in its place. And we subtract, leaving 2x, bring down a negative 5. How many times x go into 2x? My bad. Well, plus 2 times, right? Okay. Plus 2 times, and we multiply again, leaving 2x minus 4. Subtract, and we have negative 1 left as a remainder. And how do we write our answer? Well, we write our answer, and it's remainder over divisor. So negative 1 is our remainder over our divisor. Does that make sense to everyone? If we have like a missing term in the middle, we leave a space for it. Okay, let's move on to the next question. The next question is x squared plus 7x plus 12 over x plus 2. 도경아, 이거 했어? 도경아.
네, 형.
이거 풀었어? 이 문제?
저 이거 헷갈려가지고 이거 그냥 그 각 x 제곱에도 x 플러스 2로 나눠주고 하는 거 맞죠?
오, 팩터를, 이거 윗부분을 팩터를 냈어?
네, 분수치로 해서 x 플러스 2분의 x 제곱을 하고
이렇게
근데 일단 답은
아닌데.
저 parentheses x plus 3 parentheses 닫고 parentheses x plus 4 분의 x plus 2 확신이 없었어요.
아, 이렇게 했다고.
네,
이걸 factor에서 so let's do this example as well. So this is factored, but it's not divided because there's still this fraction sign. So we do the same thing as before. We have to solve this problem like this, where this x plus 2. And how many times does x go into x squared? Well, x times. I'm going to do it fast since you guys should be used to it. We subtract, leaving 5x. Bring down a 12. How many times does x go into 5x? 5 times. You multiply, you subtract, leaving 2 as a remainder. So our answer should be x5 plus 2 over x plus 2. Okay? Let's move on to the next question. Our next question is x squared. Okay, so this question is like this question where we don't have a middle term over x plus 4. 설리나 이거 풀었어?
Yes. 네. I got x minus 4
x minus 4.
plus 17 divided by x plus 4.
17 divided by x plus 4. Okay, nice. Did anybody else get a different answer, or did everybody else get that?
I got the same answer.
Okay, let's move on then. Let's finish this section actually. X squared minus 9x plus 14 over x minus 5. 이건 유겸이가 물어볼래?
X minus 4
x minus 4.
and negative 6 over x minus 5.
Negative 6 over x minus 5. Did everybody else get this? Hopefully everybody else got the same answer. And let's move on. We have 2 more questions. X squared plus 4 over x minus 3. And x squared plus 3x plus 9 over x minus 2. 이 문제는 지원이가 해보자.
진짜 계속 설명해 주는데 이해가 안 가요.
아, 이해가 안 가?
네.
그럼 그래. 이건 풀었어? 이게 조금 더 쉬운데.
그 equation formula가 잘 이해가. 그 중간에 뭐 넣는다는 게 잘.
오케이. 그럼 이거 윗부분 다시 한번 풀어보자. x squared. Well, again, we don't have a middle term, right? It's x squared. It should be x squared, something x, and then a plus 4, right? But we don't have a middle term here. We're missing a middle term. So we add a 0. Because adding a 0 is the same thing, right? X squared plus 4 plus is the same thing as x squared plus 0 plus 4. So we can add a 0. And we divide by x minus 3. how many times does x go into x squared? Well, x times, and we multiply. X squared minus x times x minus 3 is x squared minus 3x. And if we subtract, we get 3x, 4, since we bring down a 4. How many times does x go into 3x? Just 3 times. And we multiply again, leaving 13 as our remainder. So our answer is x plus 3 plus 13 over x minus 3. 이해 안 가는 부분 있는 사람? 아직도? 있어도 돼. 괜찮아. 그냥 편하게 말해.
간단한 문제라면 이해가 가는데 조금 복잡한 문제라면 이해가 안 가요.
아, 조금 더 복잡하면? 나중에 워크시트에 조금 더 어려운 거 나올 때 이해가 안 간다고? 이건 간단하니까. 오케이, 그럼 나중에 해볼 거니까 일단 다 여기까지는 이해가 됐지?
네.
네.
오케이, 넘어가 보자. 아니다. 이거 그냥 스킵할게. 이해됐으니까. 이해된 것 같으니까. 다음 부분이 조금 어려웠을 거야. Dividing polynomials by linear fractions. x cubed minus 4x minus 15 over x minus 3. So this is a bit more difficult, right? This time we're not missing a x, we're missing a x squared. So when we rewrite this x cubed, we leave a space here. And then we write, oh wait, not a plus. We leave a space here. And then we divide. Does that make sense? Why we put a 0 here?
Yep.
Okay. And then we do the same thing again. How many times does x go into x cubed? Well, x squared times. I'll do this really quickly. Plus 3x squared minus 4x. How many times does x go into 3x squared? Plus x times. And we subtract, leaving 5x, bring down the negative 15, and 5 times 5x minus 15, subtract, and we get a remainder of 0. So our answer is just x squared plus 3x plus 5. Does that make more sense for these complicated problems?
Yeah.
Okay, let's try some more then from our homework. The next problem is 5x cubed minus 22x squared minus 17x plus 11 over x minus 5. 이거 푼 사람 있어?
저요.
아니면 설린이가 풀었어? 응? 누가 또 말했지?
저요.
유겸이도 풀었어? 오케이.
응.
그럼 일단 설린이가 이거 풀어보자.
5x squared plus
5x
3x minus 2
minus 2
plus 1 divided by x minus 5.
x minus 5. Okay. Did everybody else get that?
Yeah.
Okay. The next problem is 4x cubed minus 14x squared minus 7x minus 4x minus 4. 이건 유겸이가 해볼래?
네. 4x squared plus 2x plus 1.
Plus 1. Okay, that's it, right? Okay, did everybody else get that?
Yes.
Okay, let's try. I'm gonna pick a problem that might have been a bit difficult from the homework. 3x cubed plus x minus 11 over x plus 1. Did anyone solve this?
Me.
설린이가. 오케이, 이거 뭐 나왔어?
3x squared
Mhm.
minus 3x plus 4 plus negative 15 divided by x plus 1.
X plus 1. Good job. Okay, I think everybody grasped a gist of how to do this. So let's move on to a word problem. The first word problem. I'm just going to read it. The polynomial p of x is x cubed plus 3x squared minus 4 has a known factor of x minus 1. Rewrite p of x as a product of linear factors. Was anybody able to solve this one?
Me.
Oh, okay. What did you get?
Wait, what number is this? I wrote numbers next to my answers.
It's number 1
Oh, in the
in the word problem thing.
yeah, I think I found it. Parentheses x minus 1
Mhm.
parentheses, and then a new one, parentheses x plus 2 parentheses squared.
Okay, nice job. The next one is, it says the polynomial p of x is 2x cubed minus x squared minus 25x minus 12, and it has a known factor of x plus 3. Rewrite p of x as a product of linear factors. 설린이 말고 다른 사람 이거 풀 수 있었던 사람 있어?
저 했는데 맞는지 모르겠어요.
그럼 답 알려줘봐.
Is it parentheses x plus 3 parentheses another parentheses 2x squared minus 7x minus 4 parentheses?
Wait. Okay. X plus 3 and
Yeah. 2x
2x
squared
2 squared. Okay. Like
minus 7x minus 4 parentheses.
minus 4 parentheses. Like that? Okay. Wait. Yeah. You can factor this one more time. I think. Yeah, I'm pretty sure. Yeah. So this is a trinomial, right? So you can factor 2x squared minus 7x minus 4. So what can we factor this to, right? Well, 2 binomials, we know for sure. 2 binomials where the first term equals the first term and the last terms equals last term. So our first terms is 2x squared. So the only combination is 2x times x, right? Because x times 2x is the same thing. So let's write 2x and x here. And negative 4. What can negative 4 equal? Well, it can be 2 and negative 2. Or it can be 4 and negative 1, right? I mean 2 or negative 1 and 4. So which one do we use? We need something that equals negative 7 when we add it or multiply it. And the only thing that's possible then, wait, this is a 1 and a negative 4, is this last one. Because if we write negative 4 here and 1 here, negative 4 multiplied by 2x is going to be negative 8x times x is going to be positive x, leaving negative 7x. So we can factor it into these 2 binomials. So The answer should be this. Does this make sense?
Yes.
Okay, let's skip to the next section. Polynomial remainder theorem. Number 1, who wants to take a go at number 1? Anybody that solved it? Whoa, who's Sarah? There's like a new person. Nobody solved number 1,
Is
polynomial.
the answer 8?
8. Okay. 8 is probably right. Yeah, 8. Did everybody else got 8 right? Or everybody else that solved it? Okay. Let's just move on then, I guess. Was this section hard for people, or are you like not answering because you didn't solve it, or you didn't know how to do it? Or...
It was hard a bit.
Oh, it was hard? Okay, let's go over number 2 then, I guess. P of x is given as x to the 4th minus 2x cubed minus 3x squared plus 4. So our question is, what is the remainder when P of x is divided by x minus 3? X minus 3. Remember the form x to k, right? K is what we're solving, what we're finding. In this case, k is gonna be 3. So we just plug in k into the equation, and that should be our remainder. Let's try plugging in k, which is 3. So 3 to the 4th minus 2, 3 to the 3rd minus 3, 3 to the 2nd plus 4. If I simplify that, that should be 81 minus 54 minus 27 and just 4. Simplifying that further, 85, 70, 81. I think I just get 4. This is just arithmetic from here. So all you really need to get is this portion and what you need to plug in. Do you guys get how the remainder theorem works now? Or okay. Are there any more questions about the homework? Anything I should explain more? Or is that good for everyone?
Could you explain
Yes.
the below question?
The below question?
Yeah, I didn't know what to do in that.
Okay, what is the below question?
The last one?
Last one? Okay, so P of x, correct me if I'm wrong. This is your question, right? P of x is negative x cubed plus cx squared minus 4x plus 3. This question? Right? Okay.
Yeah.
Our question is, find the value of c so that the polynomial is divisible by x minus 3. So this has to be divisible by x minus 3. X minus 3 times something. This could be this. Let's say a for now. X minus times a is going to be negative x cubed plus c squared minus 4x plus 3, right? So, oh wait. Yeah. So, okay, no, sorry, I did not explain this well. What it means by divisible is that there are no remainders, okay? So like when it says that this is a factor of this, or this is divisible by this, that means it's perfectly divisible, right? So there are going to be no remainders. So when we plug in a number, we don't know what the number is for say, but when we plug in a number in the equation, we should get 0. Okay, so here it's saying it's divisible by x minus 3. So our k value is going to be 3, right? So what should happen is when we plug in 3 into this equation, I'll write it down, the 3 cubed plus c 3 squared minus 4 3 plus 3. Our answer should be 0. Okay, so all we have to do now is just solve for c. 3 to the third power is going to be negative 27 plus 9c minus 12 plus 3 equals 0. Let's combine like terms. These three numbers equal negative 36, and we're left with a 9c. And we move 36 on the other side, and c equals 4. Does that make more sense now? What it means by divisible?
Yes.
Okay. Let's quickly move on to our lesson today. I mean, I've said this for every lesson, but I think this is by far the easiest lesson that you guys are going to learn. It's graphs. So you guys are going to do fine. So polynomial graphs. So when you look at it, that's a bad line. When you look at a graph, right? For example, y equals x squared. Our graph looks something like this, right? And it touches x right there. And we are looking at solutions of graphs this time. We know what the shape of the graph looks like, but what does it mean to find the solution of the graph, right? Well, basically, we set y equal to 0. So this is our equation for this graph. And we set y equal to 0 so we can find what x is. In this case, it's pretty simple. X is just equal to 0. That's our solution. This is what we call a solution. And we can check it using the graph. You see that the graph intersects the x-axis at 0. This is 0, right? So it makes sense with the graph. That's basically what graphs are used for, I guess. So let's try a problem. A polynomial, p of x, has zeros of x equals 0, x equals negative 1/6, and x equals 2, per se. So we know that it has these solutions, right? Well, if we looked at the graph, then we know that it needs to touch this point, 0, it needs to touch 1, 2, this point, and negative 1/6, which is like here, right? So our graph could be anything. It could be anything at all, as long as it touches these 3 points. So it could be something like this, or something else. It could, yeah, anything. But it touches these 3 points, so we know that this graph works. Any questions from what I explained so far? Or does that make sense to everyone?
Yeah, I think so.
Okay, so we can, knowing this information, right, we can estimate equations, I guess. We can like guess equations. So let's try another example. Polynomial p of x has zeros of x equals 2, 4, and -3, let's say. And we're said, what is the equation? What is the equation of this, of p of x? So we just want to know the equation. Remember when we did this, you set y equals to 0 to find the solution. So our equation is going to be p of x equals something, and we're going to set p of x equal to 0. And when we do, we should get these three solutions. Well, what you do is you write them in the factored form. I'm going to give you the answer right now. Tell me why you think I wrote it like this. It's x minus 2 when our solution is 2, and x minus 4 when our solution is 4, and x plus 3. Why do you guys think that the signs are the opposite when you write it in this way? Nobody? Okay. Well, you have to put it in the opposite sign so that when you set it equal to 0, like that, you can solve for x, right? Now, this is the same thing as x minus 2 equals 0, x minus 4 equals 0, and x plus 3 equals 0. And you move 2 to the other side, so you get a solution of x equals 2, x equals 4 here, and x equals -3. So remember that when you have solutions and you want to put it back in the equation, you have to switch the sign. So it's x minus 2, like this. Does that make sense?
Yes.
Okay, let's move on then. Just erasing. So the next thing we're going to cover is positive and negative intervals. Positive and negative intervals. Before I explain this, I'm going to explain to you what the general shape of graphs are. This actually might be tricky for some people. It was tricky for me. Y equals x, right? If we add a degree, x squared, you get this kind of graph. Okay? And if you add another degree, x cubed, you get this kind of graph. But funnily, is that a word? Yeah. If you add another degree, you get this kind of graph. And if you add another degree, you get this kind of graph again. Does anybody see a pattern so far?
Every
Yes.
3, yeah.
Right? If it's an even number, if the exponent is an even number, it's gonna look like this. The more higher it is, the more boxy it looks, like that. And if it's an odd number, it's gonna look like this. And the more higher it is, the more higher the exponent is, the more boxier it is as well, right? So you have to memorize these shapes. And well, you really have to memorize only 4 different types of shapes, which is x cubed, right? This is x cubed. But you want to also know this shape? What do you think this shape is? What do you think the equation is? Anybody? You can just shout it out.
Negative x squared?
Negative x
Cubed.
cubed. Yeah,
Yeah.
that's right. And these are the 4 types of graphs you want to know. Well, this can be x squared, x fourth, and this is negative, right? X squared, or negative x to the 4th, or negative even something, even exponent something. What really matters is the end behavior. The end behavior of the graphs. This goes on positive forever. This goes on negative forever. This goes on negative forever, and this goes on positive forever. And these two, it goes positive forever and negative forever here. You really want to memorize these types of graphs. I'll show you what I mean. So positive and negative intervals, right? So let's say f of x is equal to x minus 2, x plus 4, x plus 5, x minus 1, and x minus 9. So that's our equation. And if I ask you, what is first, what is the degree of our function here? Degree. Degree. Well, degree is basically the highest term, x, right? So our highest degree is going to be x to the 5th. So our degree is x to the 5th. So we don't know what the graph looks like, but we do know that it's gonna look something like this. Okay? In the middle, anything can happen, but we know that the end behavior here is gonna go positive forever and negative forever, because this is a odd term. Okay? Does that make sense?
Yes.
Okay. So we actually do know what will happen in the middle though, because we're given zeros, right? Let's plot these zeros on a graph. What's our first zero? 2. 2 is our first zero. Negative 4 is our second zero. Negative 5 is our third zero. 1 is our fourth zero. And 9, you know what? Let's not do 9. Let's do something like 4, because that's an easier graph. So we know that the graph has to pass through all of these points, right? And we also know that it's going to go positive forever and negative forever. So what we do is we just connect the dots. Goes down, it has to go down because it has to match this point. And anything can happen here, but we know that it's going to go back up here. And we know that it's going to go back down here. And we know that it's going to go back up here. Anything can happen here too. It can like go all the way up here like that. It can only be like that. But we do know that it has to go back to this point, right? But we see here that there's a pattern. If we draw this out, this is always positive. This is always negative. This is always positive. This is always negative, and etc., right? So our question is, what is the sign between negative 4 to 1? Well, negative 4 to 1 is right here to right here. And anything can happen here, whatever, but it's going to go back to this point. And everything below this is negative. So our sign is going to be negative. Does that make sense?
Yes.
Okay. Hopefully that made sense to everyone. Okay. So that's how you find signs between different intervals when given an interval. But let's look at zeros of polynomials. I'm going to give you an example. Let's go back to this example. It's y equals x squared. And let's do example like y equals x. Okay. What do you think the biggest difference between these two graphs are? This graph and this graph. What's the most striking difference to you?
They look different.
Okay, they do look different, but what else? Can you elaborate on that?
The left
What
one
looks
goes positive and the right one goes both ways.
Okay. Right. The end behavior. This one goes positive and this one goes positive, but this one goes negative and this one goes positive. What else?
The x squared and the x.
X squared and the x, right? But let's just focus on the graphs right now. Let's say we didn't know the equations.
Oh, what is a straight line? What is a curved line?
Yeah, you're getting close to the point I'm trying to make. One is a curved line, right? I'll explain what I mean. One is a curved line. How is that important though? You see, the zero for this equation is 0, right? X equals 0. It crosses one point in the middle, but the 0 for this equation, it's the same. X equals 0, right? But there's actually 2 zeros to this equation in this equation because the exponent is 2. Whatever the exponent, the highest degree is, let's say it was x to the third, then there has to be 3 solutions. So it has to x equals something, something, something. If there's only one, there's only be one solution. See here, in this example, it's x squared, and that must mean there's going to be 2 solutions. But if we look at the graph, we can only see one, right? Just x equals 0. We know that the end behavior, it's going to go positive and negative forever, so it can't come back down and go back down like that. That's impossible. So where is the second 0? Well, this 0 actually repeats. So our first solution is x equals 0, and our second solution is also x equals 0. That's why the graph bounces. You see how it doesn't go through the x-axis like this? In this case, it went through the x-axis because it only has one solution. But in this case, it bounced off the x-axis because it has 2 solutions at the same spot. Any questions on that? Hopefully that made sense. Nobody has questions? Everybody got that? Wow.
Yeah.
Okay. So, okay, if everybody got that. I'm going to draw a quick graph. Let's say okay, that's really badly drawn, but whatever. Wait a minute. What do you think the solution to this graph is from these 4 equations that I wrote? By the way, that's 1. That's negative. That's negative 2.
The second one.
The second one, right? Does everyone know why it's the second one? Or is anyone confused on why it might be the second one?
I'm
Wait, is it
confused.
because it made it bounce back down?
Right.
Oh,
That's why. You see, these solutions are all the same at 1 and negative 2. But the difference is that in the second one, x minus 1 squared, right? So we know that the graph has to bounce at solution x equals 1. And if you look here, it does bounce indeed. That's a bounce. I'm bad at it, but that's a bounce. And at x equals negative 2, since there's only one solution, it just has to pass through. It cannot bounce. It has to pass through. That's why it's second equation. Okay, does that make sense?
Yes. Yeah.
No more explaining. Okay, nice. We talked about end behavior a little bit, but end behavior is actually really, really important. So you guys really want to put memorize that. Keep it in your brain. Because you're gonna do a lot of end behavior problems. I'm gonna give you one right now. Let's say negative 9x cubed plus 7x plus 4x cubed. That is our equation. What do you think the end behavior will be? As x goes to infinity, as x goes to infinity, so this way, what does p of x equal? P of x is going to be either infinity or negative infinity, right? Is it going to go this way or this way? Any guesses, or anybody know how to do this? Nobody? Okay. Well, remember we said there was a pattern. So x cubed was like this, x to the 5th was also like this. Well, this is following the same pattern. X to the 9th. All we want to look at, by the way, is the first term. We can just ignore everything in the back if we're only looking for end behavior. The first and the first term, the highest term. That's the most important thing we want to look at. So x to the 9th. Well, it's an odd number. What does an odd number tell us? Odd number tells us that it's going to look something like this, but there's a negative sign. So the negative sign tells us it's going to look something like this and not like this, not this graph. So if we look at this, it goes negative infinity, right? So as x goes to infinity, x goes to negative infinity. That's the end behavior of one side. So what if x goes to negative infinity? Where does p of x go? Negative infinity is this way. Is it infinity or negative infinity? Anybody? Or are you guys still confused?
Kind of.
Okay, I guess you guys are still confused. So, well, we're given the equation here, right? And in this case, it goes positive infinity. It's the same thing, x to the ninth, negative x to the ninth. So this is gonna go positive infinity. My bad. It's gonna go this way. Is it quite confusing to you guys? A lot. Quite confusing. What am I saying? Is it a lot confusing? Yeah. Is it a lot confusing? And behavior? Or
It's
how you guys?
confusing.
Huh? Wait, what? I did not
It's
hear that.
confusing.
It's confusing.
Yeah.
Okay. Let's try one more example. P of x is 3x to the fourth plus 2x cubed minus x plus. That's our equation. What are we focusing on in this equation? What do we not care about?
The stuff on the back, just the
Right?
first.
Just anything in the back. We only care about the highest term monomial. So we only look at this. So what does that tell us? Well, let's look at the exponent first. Well, it's an even number. What does an even number look like? Does anyone remember?
U.
U, right? A smiley face. So it looks something like this. And then our next step is it positive or is it negative? In this case, it's just the 3, so it's positive. So this is our answer. We write our answer as x goes to infinity, which means as x approaches this way, P of x approaches infinity, right? It goes forever up. And as x approaches negative infinity, which means as x approaches this way, P of x is going to equal infinity. That's how we write our answer. Should I do one more example?
Yes.
Yes.
I don't understand how the answer is written that way.
Oh, you don't understand this?
Yes.
Okay. How should I explain this? So this means x arrow infinity. This is an infinity symbol, which means this is our x-axis, right? And this is our y-axis, or this is also called p, or our function axis, p of x axis. Or you can also call it y-axis. So as x goes to infinity, what does that mean? Well, in this axis, as it goes to infinity, which is positive, where does our graph go? What happens to our graph? Well, our graph goes up, right? If we, let's say this graph goes on and it's at 100, then our graph, like our point is going to be all the way up here. I mean, probably higher. And if we go even more on, it's going to be even higher and higher, our point, right? So the graph is going to constantly go up. That's what we mean by infinity. That's what we mean by P of x goes to infinity. So as x goes this way, goes to the right, given by this, P of x goes straight up by infinity. It's never going to stop going up. That's why it's infinite. And the same for reverse. As x goes this way, it's going to go straight up. It's also going to go way, way high up. Does that make sense?
So in the answers, you have to put the right side one first, or does it matter?
Oh, no, it doesn't really matter. You can do this one first if you like.
Okay.
Okay. Anybody still confused? I'll do one more example and wrap it up. But any other questions? That was a good question. Nobody? Okay. Let's do one more example. F of x, let's use f of x this time, is negative 2x to the 7th plus 4x to the 5th minus 2x 4 x squared minus 5. What do we care about? When we look at this example and we're told to find end behavior, what should we look at?
The first number with the biggest
Good
exponent.
job.
What?
Just the first, like, monomial. The highest exponent, the one with the highest exponent. You're right. Okay. So let's look at what this tells us. Well, in this term, our exponent is 7. 7 is an odd number. What does an odd number look like? Does anyone remember? It's a
Scribbly line thingy.
yeah, scribbly line thingy, like that. Okay, is it positive or is it negative? Now we just look at that.
Negative.
Negative 2 is negative. So what we do is we flip this. So we flip this. Okay, so that's this equation. This is not the equation that we're looking for. I'll erase this. This equation is going to resemble this whole function. Something might happen in the middle, but the end behavior is going to be the same. So let's write our answer down. As x approaches infinity, what happens to f of x? Somebody tell me.
Negative
Negative infinity. Correct.
infinity.
As x goes to negative infinity, what happens to f of x?
Positive.
Positive infinity.
Do you have to put
And
the as in the front?
yeah, that's how you usually write it. As this is how you normally write your answer.
Okay.
Okay, that's it. Any last questions? Or everyone good?
Yep, I get it.
Okay. I guess that's it for today then. I'll post the homework on Google Classroom. Good work,
Okay.
everyone.
Thank you.
Thank you so much.
See
Thank
ya.
you.
Thank you.